This is Kaitlan Tseng doing problem 29 from chapter 5, and it states that a block is given an initial velocity of 5 meters per second up a frictionless 20-degree incline. How far up the incline does the block slide before coming to rest? So for this problem, I drew a free body diagram. So we have our 20-degree incline, and I've designated this as the positive x direction and this as the positive y direction. So this is our block, and we have normal force perpendicular to the surface in the positive y direction, and we have our weight, or mg, straight down, and we have the components of our weight. So this is mg cosine 20 degrees in the negative y direction, and this one is mg sine 20 degrees in the negative x direction. And so I'm going to sum the forces now, and for this problem we don't need to sum forces in the y direction because the information we get from that is not relevant to the problem. So summing forces in the x direction, we get negative mg sine 20 degrees is equal to mass times acceleration in the x direction. So the masses cancel out, so we're left with negative g sine 20 degrees is equal to acceleration in the x direction. So acceleration in the x direction is equal to, if we plug in values, negative 9.8 meters per second squared times sine 20 degrees. And that becomes negative 3.352 meters per second squared. So now that we have our acceleration in the x direction, we're going to use a kinematic to find the distance the block slides up the incline. So we're going to use velocity final squared is equal to velocity initial squared plus 2 times acceleration times displacement. And our final velocity is 0 meters per second because it comes to rest. Our initial velocity is 5 meters per second, which was given in the problem. And our acceleration is what we just found earlier. And we're solving for x. So after simplifying that, x is going to be 3.729 meters. And that's how far the block slides up the incline before coming to rest.